Okay, எதை எழுதி கொடுத்தாலும் அவன் திருத்துவான், அவனுக்கு என்ன வேலைன்னு don't think like that. Okay, please give at least a minimal respect to the evaluator. Okay, we are taking the class and only they are expecting output. Simply we are not giving the question paper to you people straight away to write the things. We are spending a couple of hours as a theory class, a couple of hours as a lab class, and also many platforms to learn. The quizzes, the web links, handout, question banks. How many of them read your question bank? Many of them not at all know, aware of those question bank and all. Then how we will know what kind of questions we will ask? And also see here, this person has a time to write only 3 lines about the forward bias. We spend minimum 40 minutes or 30 minutes to explain about the flavors in the forward bias, but the person having the mindset to write only 3 lines about the forward bias, not more than that. Okay, let me finish my work. You people are saying that கடமையை செய் பலனை எதிர்பார்க்காது. நீ பாட்டு கிளாஸ் எடு, நாங்க பாட்டுக்கு எங்க ஒர்க்கை பார்க்கணும் தான் you people are saying, but I can't leave you as like, because your performance are indirectly evaluated my performance. Based on your results, only I am going to evaluate it. Okay, so I don't want to lose my thing. I will make you people to study in any way. Okay, hereafter you can't simply sit and go out of the class. I will find some persons who are unable to write by your own. I will make you to write, don't worry. Okay, 3 types of biasing we have saw in the last class. One is the fixed bias, another one is the voltage divider bias, and followed by we have discussed plenty of things, and the main things are the analysis, input circuit analysis and then output circuit analysis. For these 2 things you need to remember only the circuit diagram and basic Kirchhoff's voltage law. Okay, similarly stability factor we have derived. Then we found that fixed biasing have a poor stability. Can anyone tell me why it is a poor stability? Why it is a poor stability? Why it is a poor stability? Why it is
having
yes
another values other than one unity.
Okay, or otherwise, in other words, how we can tell S value is greater than
1.
1. Very good. Greater than 1 means poor. Okay, when it will be said as good stability factor, it's equal to 1. Equal to 1. Very good. If it is equal to 1, it is good. If it is less than 1, it's very good. Am I correct? Am I correct?
Yes.
Yes. So the stability factor is not good in case of fixed biasing. Therefore, and also we will learn how to draw the load lines and all in the fixed biasing. Then why it is said to be fixed bias also we know. So these kind of questions definitely, if you people are going and working in a software domain, the software domain people are going to write the coding for the electronic domain. Definitely they will ask these questions. Am I correct? Definitely they will ask at least what is transistor, then how you will write the coding for something. Okay, so don't think whatever you are reading is useless. Okay, everything is used if you know the meaning of that. Okay, yes. Then voltage divider biasing. In voltage divider biasing, simply we can't do the analysis. You need to convert your circuit into some equivalent circuit. What is the name of the equivalent circuit? Why it is called as called with that name? What is the name of the equivalent circuit, sir? What is the name of the equivalent circuit? Thevenin's equivalent circuit. Why it is named as a Thevenin? Any idea?
Scientist
name. Very good. It's like a Ohm's law. It's like a Kirchhoff's law. Okay. to honor the scientist, they gave the same name. Okay, yes. So Thevenin equivalent circuit is this. You no need to bother about how we need to convert this. Okay, because we are not doing to do the electric circuit analysis, only the electronic circuit analysis. So let we keep this procedure in your mind. Okay, open circuit voltage and the equivalent resistance seen from your that open terminal. Okay, that is your RTH and VTH. If you remember this VTH and RTH, then you can start write your analysis portion. This is my input circuit analysis and this is my output circuit analysis. And also stability factor is a very lengthy derivation. Please sit for some time and do practice that one. The mathematical thing we no need to spend much over here. So due to the purpose, we circulated these steps to you people yesterday. Is it anyone tried this one? At least 2 to 3 steps, not a whole thing I am expecting. Have you? Can you derive at least 1 or 2 steps in this, or have you understood how we derive these steps? Yes. Yes. Okay. Can you recollect and tell me what is the stability factor of your voltage divided by bias? It's approximately 1. It is good. Thank you for your answer. Okay, very good. So since here the stability factor is good, you can go with the circuit whenever you find number of applications. And some of your friend told that he saw one circuit using this voltage divider biasing. Am I correct? Am I correct? See, that is the application. Simply we are studying some equation and simply we are switching from this. It's meaningless. He have one circuit. I hope he will share the circuit by evening. I will circulate to everyone. Please watch it. How the voltage bias circuit used in a real-time application. Whenever you come to the lab session, that time I will explain you how the circuit works. Okay. Yes. Now it's by the value. It is approximately equal to 1. It is said to be good. Okay. Then. Now I need to draw the DC load line. So DC load line means I need to remember my input equation or output equation. Any idea, sir? Input equation or output equation?
Output, sir.
Obviously output. So this is my, from the output equation, what I am going to do, I am going to substitute some parameters. Okay. Here what I am going to do, we are going to replace IE with some other term. So what is the some other term? We know from the KCL IE is equal to IB plus IC. Am I correct? IB is always negligible. Any reason why it is negligible? Can anyone tell me? IB is negligible. Why? Or what may be the approximate value you people know? The base current in the transistor? Any clue? So base current is a very tiny amount of current, because please observe this circuit, please observe the circuit. Consider this as your load. Say example, let me keep it as a one LED. Let me keep it as a one simple LED. So in LED, if it conducts, it will draw some forward current, forward bias current. So whenever it forward bias, it will illuminate light. Am I correct? So whenever my transistor is closed, whenever it's turned on, it will conduct. What they are saying from this sentence means we are using it's a current, since it is a current control device, if I give IB equal to 0, whether my transistor will be act as an open switch or closed switch. If I give base current is equal to 0.
Closed switch.
Open or closed switch?
Open switch.
Open switch. Whether my LED will glow?
No, sir.
If I connect LED over here? No. If I give some tiny amount of current in terms of milliampere or microampere, if I give, it start conduct. At the time, please observe. the current, load current travels in this path. Am I correct? So if you neglect this current value, it is very minimal. What will be your equation? The emitter current is approximately equal to IC. Am I correct, sir? Am I correct?
Yes,
So
sir.
the emitterலையும் collectorலையும் load current, LED ஓட current. Say example, the typical current rating of your LED during forward biasing is a 10 milliampere or a 20 milliampere. Based on that, you will get the intensity. Okay. So current அதிகமா drop பண்ண the LED ல illumination அதிகமா இருக்கும். ஓகேவா? So it is approximately equal. Thereby, what we are going to do, we are going to replace the previous equation as like this. Then, as usual, we will come to this end result as the load line equation. Please note down this load line equation for the voltage divider biasing. Am I correct? Yes. So voltage divider biasing, this is your load line equation. Once you got the load line equation, you can start find the saturation point. Can anyone tell me what will be your saturation point? 0, comma. What will be your saturation point?
0, IC, sir.
0, comma IC in terms of VCC by RC plus RE. Am I correct? Okay. What is your cutoff point, sir? What will be your cutoff point?
VCC.
Point I am asking, you need to give two coordinates.
VCC, 0.
VCC, comma 0. Is it clear, my dear students? Yes. So don't get confused with the little change in the point. Earlier we considered this as a, this as a B. Am I correct? Don't get confused with the point letter AB. Okay. So saturation point and cutoff point. Saturation point correct irukka? Check paniko. Which one is the saturation point? This is your saturation point. So this is your cutoff point. Okay. Is it clear? It will take little time to பாரு இந்த கிராஃப் எல்லாம் அடுத்த CA ல கேட்க போறாங்க. But I am really worried about how you people are going to draw this. The neck of the moment only you people will get the answer in your social media. Am I correct? In the neck of the moment, if you draw this, where you will substitute the answer itself a big question to you people. So obviously என்ன பண்ணுவேன்? If you asking this as a question number 2, somewhere you will put and you will put some question number. Okay. உன்னோட குவாலிட்டியை நீயே degrade பண்ணி காட்டிக்காது. Okay. Even we people have some plenty of friends working in the bigger industries. In future, if they ask to refer any student, how we will refer you? தெரிஞ்சுக்கோ. உன்னை வந்து க்ளோஸா வாட்ச் பண்றவங்க நிறைய பேர் இருக்காங்க. And they will help you to climb a bigger positions. IBM ல இருக்காங்க, Infosys, plenty of companies ல work பண்ணிட்டு இருக்காங்க. Our classmates and colleagues. Okay. Don't underestimate and make you to underestimate you. 2 செமஸ்டர் தான் வரப்போறோம். அந்த 2 செமஸ்டர்ல நீ இதுதான் அப்படின்னு உன்னை ஆன்சர் சீட்டை வச்சு நாங்க செட் பண்ணிட்டோம்னா we are unable to refer you in near future. Am I correct? Don't show your bad things to your teachers because we are going to play with you in a short time, but we will remember the things. Based on that only we can refer you in future. Okay. I hope you note down this one. Am I correct? Shall we move from here? Shall we move from here? If you say, I will move. Make it fast. Yes?
Yes, sir.
Yes, sir.
Yes. Then why it is called as a self bias? There is a question. Am I correct? Why it is called as a self bias? So that is the reason below that. Please read. This is the circuit, is the bias regarding your biasing circuit. So in the biasing circuit, this is the equation. This is your KVL equation. Then if you closely observe this equation, once the temperature is increases, it tends to increase your beta. What is your beta? What is your beta? It's your current gain. Am I correct?
Yes, sir.
Beta current gain. So this current gain will increase something. Can anyone recollect and tell me? In thermal runaway also we have to discuss this one. The beta will make something to change. What is that?
IC
Very good. IC. This IC will make to change something. What is that?
temperature.
Temperature. The increase in IC will make the temperature to increase, as well as your emitter current will also get increase. This emitter current will increase the drop across. Please observe, this is not a simply IE into RE. That means what? The voltage drop across this resistor. Increase agma. If this term increases, in turn, it will decrease your VBE. It will make your VBE to decrease. This increase அப்படின்னா இந்த கக்ராஸா இருக்க drop will get decrease. If it VBE decreases, it will make your base current to decrease. இது எல்லாமே ஒரே லூப், ஒன்னு டிபெண்ட் பண்ணி இருக்கு. ஓகேவா? The beauty of this thing is very simple. If base current decreases, this in turn will decrease the collector current. If collector current decreases, what will happen? Anyone tell me?
High emitter current decreases.
Okay.
Temperature increase.
Temperature
Increase also.
collector current decrease ஆகுது. Please observe.
Temperature decrease also.
Decreases. Automatically this phenomena will get correct by its own. Am I correct? It won't cumulatively increase. Am I correct?
Yes,
See,
sir.
this IC automatically will control your temperature. Therefore, this circuit is called as a self-biasing circuit. See, it's very simple. We are teaching something. You are learning something by your own, and you are writing something. If you are making some correction, yourself you will take a remedial action. Can understand the class very next day. Am I correct? That is called what? Self correction. Self நம்ம எதாவது பண்ணும்போது you no need of any external force make you to do it. Happy நடக்கும் the process. Am I correct? Please do that. Whoever not having that habit, please tend to have that habit. Find it yourself. What are all the merits and demerits of mind? Today you sit for some time, put on tabulation. What is the advantage and what is the merits and demerits by your own? Write it everything over here and try to bring all the demerits into your merits by doing some exercise. அதுக்கு நான் தண்டால் எடுத்த சார் எக்ஸசைஸ் பண்ண வந்துருச்சான்னு கேட்காத. Okay. And one more thing I will tell you, we are bothering about plenty of components. Okay, we are bothering about the PN junction diode, we are bothering about the transistor, we are bothering about many things. Have you drawn the characteristics of your own? Let me break the line. இந்த பாரு நம்ம application யூஸ் பண்ண பாருங்க. Now, can anyone tell me your date of year? Approximate date of year?
2002 to 2003 வரும் sir.
Okay, 2002. Now what is the year, madam? 20?
1.
This is a time scale. This is your performance scale. Not a graph. நீ எங்க இருக்குன்றத please check it. What you need to do the remedial action, think it, adopt it, and try to be in the positive quadrant at least. Because many of the time When you reach your final year, you people are falling into the negative graph. You are forgetting everything. Even bias spelling kata you will think. And also language is a very important thing. Whenever you chat, type something, don't write some short languages. You will forget the spelling of these things. Okay. Please plot this graph and send it to me personally. Let me check your performance and I will give some tips you people to boost further. Okay. You can take it as anything in the y-axis. Not a mathematical skill, analytical skill, not a programming skill, any sports, anything. See, if you start plotting the graph, you won't get the time to finish the graph by your own. You have plenty of things in you as a skill. Am I correct? And the skill of what I did. You can put a bar chart, 5 graph for you people, what you are now, right now. Do it this one. Apart from these things, health wise, நான் எப்படி இருக்கிறேன். You don't need to approach the doctor. You can see your graph. எப்படி இருக்கிறன்றதை நீ graph பார்த்தாலே உனக்கு தெரிஞ்சிடும். Am I correct? Do this kind of things. You are not finding the things to write by your own, draw by your own. Write some coding, pass some variables, and make your coding to plot your graph. Do you know how to plot the graph by using the coding, sir? Do you have any special tool to plot the graph? Have you studied the plot and how to plot the two-dimensional plot using the array values? Hello?
No, sir.
Okay, not yet. Please try it. On the day itself, one of the students asked, sir, how to get the VA characteristics? Who asked that question? So multi-similar, we are not getting this characteristics. Am I correct? Who asked that? At the end of the
Sir,
last.
myself.
Have you tried, Mark? Have you tried this?
Sir,
Okay, do one thing. Today you go and sit with the Excel and try to get this graph. Excel is the very fundamental programming software. There you can program many things, learn it by your own, and you find any other platform to draw the two dimensions thing. At least at the end of the semester, I need the code to plot this. Is it clear, sir? I think you people definitely will try this. Okay. Yes, come back. Q point won't change. See the beauty. See the beauty. If IC is compensated by the circuit itself, my operating point won't change. Thereby, it's a good stability. So the voltage divider biasing, good stability, or the fixed biasing is it's not a good stability. How we are finding with the derived result as well as this performance. In the performance, as far the stability is concerned, Q point is the important point. I know you know in the fixed bias, it is the oscillating one. Am I correct? Q point will oscillate, but here it won't oscillate. See, if you forget that one, let me show that in fixed biasing, the end of the fixed biasing, we discussed that the quality the Q point is not a fixed one. Have you noted in your notebook and have it? See here. See here. IC varies, then Q point also varies. It leads to poor stability. Am I correct? Am I correct? So in this way, you can make a comparison. I will tell you one thing, get one bigger A2 sheet. A2 sheet, put a number of comparison tables and write all the content related to that. Then you no need to take a notes during your examination. Simply if you paste the A2 sheet somewhere in your home, if whenever you are brushing your teeth and you are roaming there, simply you see what you have written, pictorially it will get stored. Then you no need to worry about that content. Okay, these are all some tips I can give, but you will ask, we are not a school student, sir. We won't follow what you are saying. Good, no, let me a engineering student for some other thing to learn the concepts. Okay, write some coding and keep it somewhere and whenever if you want to execute it and check the output, that is also good. Okay, yes. So I hope you people are having calculator in your hand. Shall we start to the first question, please? Theory portion over. Shall we start? See, well, we
Yes,
have
sir.
minimal sums. Okay, 4 sums hardly we have. Fifth one is very design oriented. I will give you the question and answer to you people. Whoever really wants that, practice that one. Okay. Yes. Shall we start? I hope everyone having the calculator. Okay. Why the assumption? Can you people turn on your camera and show your calculator? At least one or two having the calculator. Let me know and start teach the thing. Please turn on your camera and show your calculator, please. Who are having the calculator? So you know that manual calculation is not much accurate, much fast. Due to the purpose only you join this course. Am I correct, sir? Manual calculation is sufficient abina. What is the need of computer science? Am I correct? Am I correct? Am I correct?
Yes, sir.
Computer science students not using the computational tools. Then who will use that? Okay, please, if anyone having the calculator, please turn on your camera and show your calculator. Is it no one having the calculator in your hand? Is it anyone having calculator, please? Is it I intimate a little advanced to you people? Yes, thank you. Thank you. Who's that? Who's that? Darun, thank you, Darun. Thank you very much. Anyone else having calculator in your hand, please? No one except Darun. Siddheswaran, thank you. Siddheswaran, but you have some advanced calculator, am I correct? Okay, now you can use it, but okay, no issue. Whenever they are coming for the offline exam, please change that one. Okay. Yes, anyone else? Anyone else in A class, please? A class, anyone having the calculator? Yes? Please tell your name if you are turn on your camera. Thereby I can check you are having the calculator. Is it anyone having the calculator? The A class? No one. Niranjana?
No,
Srihari? என்னாச்சுமா கால்குலேட்டர் ஒன்றும் வாங்கலையா?
no, sir. இனிமேல் தான் சார் வாங்கணும். சொல்லியிருக்கேன் சார் அப்பா கிட்ட.
கொஞ்சம் குயிக்கா before the exam. See, if you buy the calculator within the semester, we will teach you how to program your calculator. Repeated calculation, even though it is a non-programmable calculator, in a limited way, you can automate some readings. At least in the next lab, please have the calculator. I will teach you how to program that one. That will reduce your calculation time. Okay, அப்ப A classல யார்ட்டுமே இல்லையா? ஸ்ரீஹரி, ஆதித்யா,
சார் இருக்கு சார்.
அஜய்ராம். அப்ப கால்குலேட்டர் காட்டினா திட்டுவாங்கன்னு காட்டாம உட்காந்துருக்கிறியா ஃப்ரெண்ட்ஸ்?
சார் இல்ல சார், லேப்டாப் யூஸ் பண்றேன் சார்.
சரி, ஓகே, லேப்டாப் ஓகே. சரி கண்ணா, who don't have the scientific calculator, please buy the calculator. At present, please make use of at least your mobile calculator to calculate. Okay, I think many of the mobile phone having the scientific option. Please at least select that one and calculate yourself. Okay, read the question and go through the diagram and tell me how we can proceed this. Make it fast. Yes. Read the question. Read the question and observe the given circuit diagram and tell me how we can proceed. Have you note down the question? Yes.
Yes, sir.
Tell me, what is the thing I need to calculate?
So you need to calculate the Q points.
Q point.
To the rates.
So I think this is our output characteristics. Am I correct? And this is our load line. This is our what? This is what?
DC load.
This
DC
is
load.
our no. This point.
Q point.
This point. Q point. Am I correct? So without doing this graphical things, we can calculate this. That is the first point. Okay, that we will see. Then DC load line. Two things you need to do. Okay, can you tell me one thing? Whether you need to present some drawing at the end result? Any graphical thing you need to show to the evaluator?
Yes, sir.
What is that?
DC load.
DC load line you must draw. DC load line you must draw. That means for this question, Kanad, one more thing I need to tell. Somewhere we given as a 1.21. இது யாருக்காவது நாம இருக்கா கொஸ்டின்ல CA1ல? Ripple factor, correct? Ripple factor of full wave rectifier or half wave rectifier? நம்ம மக்களுக்கு ரிப்பிள் ஃபேக்டர்ல ரெண்டு டைப் இருக்குன்றதே தெரியாம they copied some other ripple factor and surprisingly this is the thing given to prove they unknowingly they proved that it has a 0.48. How innocent our friends are. இது எனக்கு டைஜஸ்டே பண்ண முடியலடா கண்ணா. We gave the answer to in your hand. See, if you are giving you asking you to derive and find ripple factor, and if you are committing the mistake, okay, it is acceptable. இங்க ஆன்சரே கொஸ்டின்ல கொடுத்துட்டான். நீ வேர்வை சிந்தி உழைச்சு தப்பான ஒரு ஆன்சரை கொடுத்து ப்ரூவ்ட் அப்படின்னு எழுதுற. நம்ம எவ்வளவு இன்னசென்ட்னு பார்த்துக்கோ. நம்ம டெக்னிக்கலா ஹவு மச் வி ஆர் புவர் அப்படின்றத அண்டர்ஸ்டாண்ட் பண்ணு ஃபர்ஸ்ட். எனக்கு வந்து கண்டென்ட்டை ரீட் பண்றதை நான் எவ்வளவு அவசரப்பட்டு ரீட் பண்றேன், எப்படி அர்ஜென்ட்டா நான் காப்பி அடிக்கிறேன் பார்த்துக்கோ. 1.21 கொடுத்துருக்கு, அவன் வேறு சிந்தி உழைச்சு ப்ரூவ்ட் ஆஸ் 0.48 சொல்றான். புரியுதா? உங்களோட அந்த ஸ்கில்ஸ் நீங்க எப்படி வந்து பாசிட்டிவ்ல இருந்து நெகட்டிவ்க்கு போயிட்டு இருக்கீங்கன்னு தெரியுதா சார்? புரியுதா? ஸ்கூல்ல இருக்கும்போது நம்ம எங்கேயோ இருந்தோம் டாப்ல, காலேஜுக்கு வர இங்க கீழே போக ஆரம்பிக்கிறோம். If you proceed the same and if people are failed to point this, you will find that it is the correct path to travel. இப்போ 4வது வருஷம் பார்த்தீங்கன்னா குளியில கிடப்பு. Please come up. We triggered you, we pointed your mistakes. Please accept those mistakes and correct it yourself and try to follow it in the positive. Okay? Yes. So okay, let me find the operating point. So operating point கண்டுபிடிக்கணும் அப்படின்னா என்ன பண்ணலாம்? எந்த KVL equation எடுக்கலாம்? What I can do? Any clue from your side, sir? KVL எந்த சர்க்யூட்டுக்கு பண்ணலாம்? இன்புட்டுக்கா அவுட்புட்டுக்கா? அவுட்புட்டுக்கா? இன்புட் சர்க்யூட். ஓகே. ஆப்ரேட்டிங் பாயிண்ட்ன்றது இன்புட் சர்க்யூட்ல இருந்து எடுத்து அனலைஸ் பண்ணலாம் ஃபர்ஸ்ட். சரியா? ஐ திங்க் ஃப்ரம் த கிராஃப் யூ ஆர் சேயிங் தட் விசி இதுதான் சார் டிரா பண்ணோம், அதை வச்சு நான் சொன்னேன் நீ சொல்ற. am I correct? அது எக்ஸ்பெரிமெண்டா இஃப் யூ டூ ஒன்லி யூ வில் கெட் த ஆக்ஷன். ஓகே. ஸோ இன்புட் சர்க்யூட் அனலைஸ் பண்ணி பார்க்கலாம் whether we are getting the parameters. Okay. Yes. Can you tell me the KVL equation for the input circuit analysis for the fixed bias, not for the voltage divider bias? Fixed bias ganna equation, sir? Please check your class note, previous note, and tell me what is the input circuit KVL.
IB is equal to VCC minus VBE by RB, sir.
Very good. IB is equal to VCC minus VBE divided by RB. Okay. What is in your scanf? What are all things I need to scan up and what I can do it in the printf? What What are things I can scan?
VCC.
VCC I can scan from my given data. What else? VBE
Given
also I can scan. Okay. RB also I can scan. Can anyone tell me what is the unknown IB, sir? Let me do
1.9 milliamps.
1 point.
9 milliamps.
Kana, see why we are insisting you people to buy the calculator and do the exercise means it is a very simple calculation. Am I correct, sir? We are going to find some different and we are going to divide with RB. We have a plenty of experience with your seniors. They will have the calculator. Okay, even if I give this step, find the answer and tell me by your own. Somebody saying that 10 minus 0.7 divided by 470k. You can't type the k in your normal calculator. What you need to do?
Into
You
1000.
need to put, you need to add 10 to the power 3. That means you need to add how many zeros?
3.
3 zeros. Add and tell me the answer, sir. How much you are getting?
So 1.97 milliamps.
1.97 milliampere is one answer. Okay. Any other answer, sir? I think this is wrong. Any other answer? I need right answer.
Many answers.
Yes. Any other answer?
1.97 into 10 to the power of
1.97 into 10 power minus 5 amperes.
1.97 into 10 to the power 5 ampere. Okay. Any other answer? I am not getting the expected answer. Is it anyone getting 9.99? Is it anyone getting 9.9? Hello? Kadakida madam? So this is option A, this is option B, this is option C. Can you tell me which one is the correct one? A, B, C. Okay. I will reveal the secret why your friend got this answer. This is the thing you need to practice. Okay. Due to the purpose only, we are asking you to bring the calculator. You know, as a C programmer, where to open the bracket and where to close the bracket. That is the basic rule is available. That is Bodmas rule. Am I correct, sir? Computer science engineer, you must know this rule. Am I correct? Bracket of division multiplication. What is this?
Addition.
addition, subtraction.
Addition. You need to write this in a vertical portion. That means which one have the higher priority? Highest priority. Bracket. Listen, this is the mathematical equation. Can anyone tell me which one I need to perform first, which one I need to perform second? The numerator portion, I need to find the difference first. Am I correct? What is the difference difference between 10 minus 0.7, sir?
9.3.
9.3. Then only I need to divide with my denominator. But how my computational device knows I need to perform this first, then I need to divide. If you keep on give the input, as 10 minus 0.7 followed by divide 470, how my computer knows I need to perform these two first, then only I need to divide. What I need to include, my dear computer science engineers?
Bracket.
Bracket. Can you realize why you need to buy the calculator and practice? See, this calculator in turn going to make you to forget many things. It will reduce your memory power. What is 1/2? You will search Casio 9 on MS. Then only you will find the what is the answer for 1/2. But that is only one negative point. The remaining things, with the help of the calculator, it is a mini computer. You can perform many things. You can program by your own. Okay. So my humble request, at least by the next class or the coming week, have the calculator in your hand, because if you see the first consecutive questions, more than 15 mark questions also maximum 15 marks you will get it from the single analytical question. Don't lose it. It will consume less time to work out than the paragraphs you need to write. Okay, so do remember these things in your mind. Whatever your friends said as the last answer and the first answer, both the things are wrong. In between they said one thing, that is what is that answer? 1 point something you told.
1.97 into 10 to the power of -5.
Now you see the beauty of one more thing. 1.97 into 10 to the power -5 ampere. How many of them having this answer in your calculator, please? Please unmute and tell yes. I will tell you one magic what you can do it.
Yes, sir.
Can உங்கள்ட்ட இந்த ஆன்சர் இருக்குதா கால்குலேட்டர்ல? Am I correct? Simply press ENG button. Simply press ENG button. What you people are getting as answer, sir? Tell me. 19.79 into 10 to the power -6. Is it gives the answer like that? Yes, sir. Answer
Yes, sir.
kudukudha. So that is the beauty of this engineering calculator. Itself it will convert it into the mere engineering terms. 10 to the power -3, 10 to the power -6 அதுவே கன்வெர்ட் பண்ணி கொடுத்துரும். ஓகேவா? ஸோ கொஞ்சம் அந்த கால்குலேட்டரை வாங்கி ப்ராக்டிஸ் பண்ணு. I don't know whether the trial period is over. Others, please try to get that answer, please. By the time my license period over. Okay, let me show the calculator demo in the next class. Okay, I have one software to demonstrate. Now the license time over. Let me request for the free version once again, and I will show the demo. Okay. Always our engineering notation, 10 to the power -3 and 10 to the power -6 and 10 to the power -9 in the same way, plus also 10 to the power 3, 6 and 9. So these are all called as engineering notation. In between also you have some powers, 10 to the power -2, 10 to the power -3, -4, -5. Any power is called as a scientific notation, but we do follow only the engineering notation. So whenever you are giving some answer, the answer should consist of either milli or micro or nano, or else simply ampere or kilo, mega or giga. Can you understand what I am saying? Can you understand what I am saying? My end result la eppadi irukano? See, if you are not much practicing this, simply you will write as whatever the answer you are getting and ampere. 10 to the power -5 ampere னு எழுதிட்டா கூட பிரச்சனை கிடையாது. The micro ampere convert பண்றேன்னு சொல்லி you don't commit mistake by your own. Okay, yes. Now, can anyone tell me from the base current, is it possible to find the collector current?
Yes, sir.
Yes, sir.
Yes. What is the formula? What is the formula to find the collector current in terms of your beta? Yes. Yes. This is your what current? See, recently only we discussed one point. Your base current is very, very less than your collector current. This is an immediate example to you people. Compare பண்ணி பாரு sir. Compare பண்ணி பாருங்க. It is microampere. அப்ப how many zeros you need to shift it? இங்கிருந்து எவ்வளவு ஜீரோக்கு மூவ் பண்ணணும்? 6 places you need to move. Am I correct? That is 0.0. How many zeros I need to put? 4 zeros, then 97. This is your base current. But it is your collector current is 0.00197. Is it clear, sir? Is it clear to you people? Why we took the assumption as the base current is negligible and collector current is almost equal to emitter current? புரிஞ்சிருச்சா? So நமக்கு நிறைய பேருக்கு சம்ம பார்த்த உடனேயே சாய்ஸ் தான் மைண்ட்ல வரும். But these practical things will make you to understand the theory concept very well. Am I correct? Paragraph படிச்சது இங்க 4 ஸ்டெப்ல அண்டர்ஸ்டாண்ட் ஆயிடுச்சா? Am I clear, sir? Yes. So now for the particular base current, this is my collector current. அப்படின்னா see, I will have plenty of outputs. இப்படி இருக்குது. நான் ஏதாவது ஒரு base current I am going to take as operating current. அப்ப அந்த particular currentக்கு வர collector current நான் என்னன்னு வச்சுக்கலாம் சார்? I can keep it as a ICQ. Is it clear?
Yes, sir.
Therefore, I found ICQ. That means the base current I am going to keep it as this value in my output characteristics. If I keep this as a base current, so my graph will fall somewhere. So இதுல வரப்போற ஒரு பாயிண்ட் தான் என்னது நான் கண்டுபிடிச்சிருக்கேன். That is my y-axis. Y-axisல current வர value I found it as a ICQ. What I need to find further, sir? VCEQ. We need to find VCEQ. So whoever failed to write, at least take a screenshot. Thereby we will move to the next step, please. Quick. Shall I move? Yes. Now output analysis. Can anyone tell me the KVL equation for the fixed bias output equation?
VCC equal to IC RC plus VCE.
Yes. Very good. What are the thing I need to scan off and what are the thing I need to print off? What is my intention here?
VCE.
What is my intention to make it print off? VCE.
Define
VCE. We need to find VCE. Is it we have enough content to substitute?
processor.
What is VCC, sir?
10 volts.
Very good. What is IC?
1.978
1.97 milliampere. Okay. What is the value of RC, please?
2.2 kilo ohms.
No. You should not write K and M as like this. Whenever you are writing the content 10 to the power minus 3, what you need to put it here? 10 to the power 3. Simply you can cancel out these 3. Am I correct, sir? Remaining alone, if you substitute, you will get the answer. Do it and tell me the end result, what you are getting, please. 10 minus 1.979 in 5.6. பத்தியா இங்க ஒரு சின்ன மிஸ்டேக் நடந்திருக்கு. இது என்ன வரணும் ஆக்சுவலா? 5.646. Is it clear, sir? Is it clear? Is it clear? Yes. Okay. Now you tell me. This VCE also called as what? VCE Also, I can name it as what? Because no, that is okay. That is okay. Whether we found the operating point, one more coordinate we got it. See, very simple,
Yes, sir.
very simple, very simple. This is the base current. I am going to keep it for the particular base current. For the particular base current, this is IC. So I am keep it as ICQ. Immediately in the next step, you observe for the particular ICQ, we are finding VCE. So I can label this as a what now?
VCEQ.
That's all. So first point over. We got 2 points, that is 1 coordinate. Am I correct? 5 point, 5 point. இங்க ஆன்சர்ல கரெக்டா இருக்குது. கரெக்டா கண்ணா 646 கரெக்டா இருக்கு. இது மட்டும் தான் சேஞ்ச் பண்ணு. ஓகேவா? Yes. 5.646. Then what else I need to find, sir? We need to find only half of the portion we have finished. We found only the Q point. Am I correct? Okay. What else we need to do in the same question? We need to draw the
Load line.
any guess from your side how to draw the DC load line? For that, I should remember one equation. What is the name of the equation? Load line equation. Am I correct? Can anyone tell me what is the load line equation for the fixed bias circuit? Yes. Yes. Okay. Shall we start find the saturation point first? Saturation point falls in the x-axis or y-axis? Saturation point in the axis level. Y-axis. Y-axis means IC எப்படி இருக்கும் sir? IC
Value.
0. ICQ, sorry, ICQ you have some value. Correct.
VCE.
Substitute here and tell me what is the IC value, please. Substitute here
VCC by RC.
value in result. Answer we need. What is the meaning of IC subscript SAT? Collector current at saturation point. Okay. Collector current at saturation point. Am I correct, sir? Okay. Tell me the saturation current point. IC.
4.5 milliamperes.
10 divided by RC 2.2 kilo ohm. 4.545 milliampere is the right answer. I hope many of them not getting this answer. At least have it in your note, and whenever you are getting the calculator and try it. Else I will give you few tips to you people for the short term. 2.22 into 10 to the power plus 3. If you bring the plus 3 top, what you will get? Minus 3. Am I correct? So simply
Yes,
calculate 10 divided by 2.2 and keep it as a 10 to the power minus 3 ampere. At the end, you will get this. This is the answer. So simply write 10 to the power minus 3 into a milliampere. Is it clear? Is it clear?
Yes, sir.
In this way also you can practice, but if you are doing these many computational steps, then you will tell, sir, we couldn't get the time to finish the answers. Am I correct? அப்புறம் எக்ஸாம் முடிஞ்சோன்னா கால் பண்ணுவேன், சார் நான் ஐ ஸ்கிப்டு திஸ் கொஸ்டின். நோ நீட் டு ஸ்கிப். சி கொஸ்டின் பேப்பர் செட் பண்ணும்போது இது கால்குலேட்டர்ல போடுறதுக்கு எவ்வளோ டைம் ஆகும் தான் பார்ப்பாங்க. ஓகேவா? தே won't think this. What is this? What is this? What is this? What is this? Manual. They won't evaluate the manual calculation timing. They will calculate only the Casio timing. Okay. Yes. Now How to find the cutoff point? How to find cutoff point? Obviously falls in which axis, sir?
X-axis.
X-axis. X-axis la is 0, sir.
IC 0.
Y quantity is 0. So I need to find this value alone. What is that? ECE.
VCC.
How much? Without calculation,
10
you can
volt.
tell. 10 volt is the right answer. Very good. Now my task is to draw the DC load line. Draw the DC load line. So these are all the point. One is the saturation, another one is the cutoff point. Now we are going to draw the point in the graph. Is it clear, sir? Is it clear? They included one more point also. What is that? Operating point also they mentioned in the load line. Am I correct? Am I correct?
Yes, sir.
By seeing the graph, what I may think, can you people say? எனக்கு என்ன பயம் வரும்? என்ன பயம் வரும் சொல்லு. எக்ஸாம்ல இது என்ன பாடுபட போகுதுன்னு பயம் வரும். கரெக்டா? கரெக்டா? எவனா சொல்றியா சார்? இல்ல சார் கரெக்டா வரைஞ்சிருவோம், நீங்க பயப்படாதீங்கன்னு. சரி, நான் பயத்தோட இருக்கிறேன். CA2 திருத்திட்டு பார்க்கலாம். சரியா? Shall I move? Shall I move? ஒரே ஒரு சம் தான் போட்டிருக்கோம், கொஞ்சம் குயிக்கா. எஸ், 5 minutes தான் இருக்கு. Take down this question. Take down this question. இந்த கொஸ்டின் பொறுத்தளவுக்கு they gave many parameters. They gave many parameters. They asked you to find what? Design base bias circuit அப்படின்னு சொல்லியிருக்காங்க. Please come to the circuit. What are all the unknown things here, sir? What are all the unknown things related to the fabrication of the circuit?
RD and RC.
அவ்வளவுதான். இந்த ரெண்டு ரெசிஸ்டர் வேல்யூ கால்குலேட் பண்ணணும், அவ்வளவுதான். ஓகேவா? Let me show the procedure to you people how to calculate. Definitely you can try it by your own. Shall I show the steps to calculate? Yes.
Yes, sir.
First one, how to find the base current. So we are going to find the base current. From the base current, we are going to find the base resistor. I need to point out only one thing to you people. By the calculation, we are getting the value of the resistor is what? 465 kilo ohm. But it is round off to 470. Any idea why I need to round off to this? Any idea? Any idea? Very good. Manufacturer, if you consider X company as the manufacturer, they won't manufacture resistor value with all the values. Only they will be having some standard values. I will share the standard resistor values in your classroom. Please have it, the standard values in your hand. Whenever you do the calculation, you need to find the nearer value in the standard table. Then you need to fetch that value. Okay. So very simple reason. This is not available in the market. Okay. Only this is available in the market. Then this is the thing to find the RB value. Then how to find the RC? RC, this is a formula we know from our previous classes. This is not a standard resistor value. The closer to this is 2.4 kilo ohm. Okay. Is it simple to you people? Calculate point, sir. Is it this very tough or it's simple to understand? இதுக்கு என்ன தெரிஞ்சிருக்கணும்? Very good. Input and output current equations தெரிஞ்சிருந்ததுன்னா can substitute these values and you will find the design values. Okay. The last sum, let me show. Try it by your own, and we will discuss the same in the next class. Okay. Thank you for your patient listening. Any doubts so far? You can ask. Is it you people will improve your thing and do show your performance in the next test, or you will be keep on in the same level?